with that. I'm going to start from right at the beginning as if you've never done anything on this before, but if you have, then feel free to kind of fast forward through sections of this video or just go straight on to the practice questions for today. So this above me is just going to kind of stay there. You can just refer back to that at a later point. We'll talk more about what it means. We're just going to go through some example questions and I'll just kind of talk you through what to do. So we'll start off with this first one. Pat has a bag of beads because, you know, she's kind of a cool person like that. So it says she asked her two friends, Owen and Maria. We'll talk about them in a second. Let's first of all talk about the bag. It says she's got 5 white and 1 black in her bag. So here's a little bag. It's like a little kind of sack, let's say. There's a little drawstring. Look at that. So it says she has 5 white beads, 1, 2, 3, 4, 5, and she's got 1 black bead. She asked her two friends about the probability of picking a black bead from the bag without looking. What do they say? Well, Owen says that it's 1 out of 5 because there are 5 black beads and 1 white bead. Maria says it's 1 out of 6 because 6 beads and 1 is black. So first thing we need to know, which of the friends is correct? Well, I hope you will realise that Owen is incorrect. He says there's 1 out of 5, but it's not 1 out of 5. Okay, it's 1 out of 6. If you think about it like this, literally 1 out of 6 beads are black. Thinking about the fraction, it's 1 black out of 6 total. So this bottom number here, okay, is very important. We always put the total on the bottom. So when we want to write a probability, we're writing it as like a how many out of how many. Here it's 1 out of 6. Notice we've written it as a fraction and not as a decimal, because if we try and write it as a decimal, 1 does not divide by 6 into a whole number. It gives us like a horrible recurring decimal. We don't want that. We've not written it as a percentage because of the same problem, but as a fraction, it fits nice and neatly. So when we're doing probability, try and keep it as a fraction where possible. 1 black out of 6, 1 out of 6. Maria. Okay, it says Tracy has a different bag of black and white beads. The probability of picking a black bead from Tracy's bag is 7 out of 13. What is the probability of picking a white bead? Well, it says in the bag that there are only, I'm going to do a different colour, white and black beads. So that means that all of the beads that are not black must be white. So we could say that white is not black in this case. Yeah, white beads are not black beads. So if we've got 13 beads, 7 are black. Well, 13 minus 7 is 6. So there must be 6 white. We could also write this then as a probability. We could say, well, the P for probability of a white bead. So this is what we call notation. P for probability, brackets what's happening, and there are 6 white out of 13 total. And that, I'll highlight it in yellow for you, would be your answer. 6 white, 13 total, 6 out of 13. Finally, it says how many black beads and how many white beads could be in Tracy's bag. And this is where we have to use a little bit of fraction knowledge. Well, we know we have 6 white out of 13 total. So we obviously can have 6 and 13. But from our fractions, we should know that, for example, what we could do is say, well, what about if I double the 6 and double the 13? I would get 12 out of 26. And those fractions are the same amount because I've done times 2 and times 2. We could, let's do a different colour, we could have times by 3 and had 18 out of 39. And so on and so on and so on. So basically any equivalent fraction we can write as our probability, because all of them will be the same. If we double the number of white and we double the number of black, then the probabilities stay the same, as long as we do the same thing to both. So you could have said 6 and 7, you could have said 12 and 14, you could have said any of those combinations. Ooh, next page. Oh, down, sorry. Okay, now the same question at the top, but it says Peter has a different bag. Okay, so we need to draw another amazing drawing. Okay, there's our amazing drawing. Put the drawstring on this side this time. It's not a very good drawstring, but we'll make it. It's got little pull strings. Maybe a little like thing, you know, like where you put it to pull it up to close it. So it says he's got a different bag. He has more beads, so he's going to have more than the 6. Sorry, more than the 13, because it's the previous question. Ignore that. We don't need that. That's from the previous question. So it says that the probability is 7 over 13. So as we were saying before, well, we could say 7 over 13, but it has to be more. So what we could have done is said, okay, let's double it. And we get 14 over 26. So that would mean that there are 14 black beads and 12, because we know that it has to add up to 26, white. So we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 white, and 1, 2, 3, 4, wish I hadn't made myself do this, 8, 9, 10, 11, 12, 13, 14. So 12 white, 14 black. Now using these, okay, we can, didn't mean to do that. We could say the probability of white, P, probability, W, white, is 12 out of 26, which is equal to 6 over 13. We can say P, probability, B, that's a B for black, is 14 out of 26, which is equal to 7 out of 13. So there's more beads in total, same probabilities, because we doubled both of them. You could have also said, maybe, again, you could have done 7 over 30. You could have times them by 10 if you wanted to. I'm not going to draw them out. And that would have given you 70 over 130, etc., etc. So it's the same probability. If it's equal, that's you using your fraction skills, then it's going to be the same chance of happening. Okay. Nope, didn't mean to do that. No, I want to go down. Okay. Let's look at a machine selling sweets. Everyone loves sweets. So they sell in 5 different colors. You can't, the choice is giving you a random choice. You don't get to choose it. And each one there's like the same number. So if there's 2 reds, there's also 2 greens, 2 oranges, 2 yellows, 2 purples, etc. So 2 boys buy a sweet. Ken does not like orange and yellow sweets. What is the probability that Ken gets a sweet that he likes? Well, he doesn't like orange and he doesn't like yellow, but he does like, that means he likes red, he likes green, and he also likes purple. So he likes 3. Yeah? There are 5 altogether. So he likes 3 of them, 2 of them he doesn't like, so he likes 3 out of 5. It says Colin likes a sweet of all the colours. So he likes 5 out of 5. But 5 out of 5 can also be written as 1, or as 100%, for example, if we want to write it as a percentage, introducing that. So when we write a fraction, we have, it's a whole number, we write 1. We know 1 is certain. You can't be more than certain. We talked about that a second ago. Or depending on when you're watching this video, we've talked about that before. So Colin likes all of them. He's definitely going to get one that he likes. So coming back to this idea of impossible to certain, remember 0 is impossible. It cannot happen. Remember, nothing can be less likely than impossible. That means literally it cannot happen. 1, of course, is certain. That's the maximum because nothing can be more certain than certain. So first one, it says, where is Ken going to come? He's going to come 3/5 of the way along. 3/5, of course, can also be written as 6/10. So 1, 2, 3, 4, halfway is here. This is 6/10, and Ken would go here. It then says label on a different one where Colin's going to come. Well, of course, Colin is certain, so he's going to come here, right at the certain end. It then says finally, Mandy buys 1 sweet. The arrow on the scale shows where she gets a sweet. Write a sentence to describe which sweets Mandy likes. Well, first thing we need to do is count the marks. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So each one is a tenth. This, of course, represents 4/10. Or 2/5. So we need something that has 2/5 in it. So again, that's the easy one. She likes 2 types, so Mandy must like 2 out of 5 colours. So basically any colours you could choose. So she maybe likes red and green. She might like orange and purple. Notice I'm using a lot of like single letters, so like O for orange, P for purple. As long as you haven't got 2 things that start with the same letter, that might help. Okay, so we can, when you're writing these things, start to abbreviate this. Okay, so now we're going to try and that was a big explanation, just try and condense it down. Okay, so first one we're going to do is the red. I should have done it in red. I'm going to do it in red. That'll be more fun. So for the first question, we're going to say the P, probability of red. Okay. Well, first of all, we need to know how many reds and how many total. So we know there's 18 reds. The total, 18 plus 12 plus 10 is 40. With probability, that's absolutely fine to leave it as 18 over 40. But if you are feeling a bit more exciting, you could say, well, I'm going to simplify it, divide it by 2, and 9 over 20 is also correct. Next one, it says the probability that it's not green. So think, if there's 40 total, that's not a word, and there are 12 green. This means that if we do 40 minus 12, that gives you 28. So there's 28 that are not green. Because all the ones that are, it either is green or it isn't green. It's one of the two. So here, 28 of them are not green. So it's going to be 28 out of 40. Or we can write it as 14 over 20, 7 over 10. So you can either simplify it or leave it unsimplified. What we try not to do is to do the ones in the middle, okay, because it's either simplified or not, original or simplified. Try and give one at either end of the spectrum. This one can be useful because it tells us, of course, the total and the number of greens. Oh, sorry, not greens. This one is simplified, and you can give either one of the answers. Sometimes the question will ask for one specific answer. Last one, it says green or yellow. So this is one way you've got to think about it, and this is a bit harder for those of you who perhaps don't have English as your first language. It's green or yellow. I always think of it like a game. If it's saying if you get a green, you win. If you get a yellow, you win. So if there's 2 colours that you win on, you have a bigger chance. So it's saying green or yellow is green and yellow together. Okay, green plus yellow. So green is obviously 12. Yellow is 10. There's 22. Because you're combining them. Because it can be either or. You've got more options. If you get green, you win. You get yellow, you win. Both of them win together. So we'd say, well, it's 22 out of 40 or 11 out of 20. So when it's or, this word or, you add them together. All right, we're almost there. Last thing to do. Okay, now it's saying not the probability. It's a slightly different question. It says you roll a dice 120 times. How many times would you expect to obtain a 6? So the first one, first thing we're going to do is talk about the probability. P, probability, 6, what's happening? If you think about a 6 on a dice, okay, I'll do an amazing dice for you. Yeah, you think about a dice in case you don't know what that means. Yeah, there's a 1. Don't know what that would be, like 3, you know, whatever. I think that would be a 5. I don't know what a normal dice looks like. I think it's something like that. So let's say you had something like that. Okay, you got a dice, normal dice, fair dice, it says. There's no weirdness about it before anyone says anything. Fair, of course, means it's a perfectly normal dice. All the things are equally likely. So you've got 1 6 out of 6 numbers. So the probability is, of course, 1 over 6. But the question says, how many times would you expect that? Well, you're saying you're doing 120 times, and it's at 1/6 the time. Yeah, so 1/6 every time, 120 times. Well, that means you're going to do 120 times the 6. Remember, you're using your calculator to help you, and if you do that, the screen goes blank, obviously. 20 times. So it's not saying what's the probability, it's saying how many times would you expect it to happen. We take what we call the number of trials and we multiply it by the probability. So if we apply that to the next question, let's do it in a nice green. It says, how many times would you expect an even score? So first thing we do is say, okay, what's the probability the numbers are going to be even? Well, you know that that's going to be a 2, a 4, and a 6 out of 6 in total. You could say it's going to be 2 or 4 or 6. That's 3 numbers out of 6 or a half. 2, 4, 6 out of the total. So we say we're going to do, don't do that, don't do that, don't do that. So we say we're going to do a half times 120 trials, and that gives you 60 times. Last one, let's do it in a nice blue. Score of less than 5, so that one's going to go here. So first thing again, P, less than 5. Notice I've used the little thing here. Now this is one that tricks a lot of students. They say, it does 5 count? Think about it like this. If you have €5 in your wallet, you have €5. If you have €5 in your wallet, you don't have less than €5. You have €5. So to have less than 5, you can't include 5, because 5 is not less than 5, it's 5. So if it says less than 5, it would be obviously 1, 2, 3, 4, but 5 is 5, so it's not less than 5. Which sounds simple, but people get that one mixed up. If it said less than or equal to, then you'd include it. So less than 5, you've got 1, 2, 3, 4 out of 6 total. So 4 out of 6, which is also 2/3. I'm running out of space. I have to write it at the top. So you'd say 120 times 2/3 is 80. So when it says how many times, just remember it's not asking for the probability, but you will need that to work it out. Okay, finally, the common questions, some of the ones you're going to do in a minute, are going to involve a deck of cards. Most of you will have played with a deck of cards, some of you might not have done. Even if you've played cards, you might not know all of the terminology, so I'm just going to help you a little bit. First of all, you may see a question that asks about picture cards. Well, that's these here. And there's 12 of these. Yeah? King, jacks, queens, kings. You may hear it talk about red and black. And we can see that half are red and half are black. So the top half is black, the bottom half is red. Okay, and it's half and it's half. Diamonds, hearts, clubs and spades, there's 13 of each suit. Ooh. I love it when it does that. Just oh, please tell me it's recording. Let's just check. Yeah, still recording. Good. Go away, little window. Okay, the inner workings. So 13 of each suit. How many are there of each card? Well, we can see, for example, 7s. Okay, there's 4 of each card. If it talks about aces, okay, you can just kind of assume that aces are like 1. Unless the question tells you otherwise. So for these questions, assume an ace is a 1. And yeah, I think that's about all the stuff you'll need. So half red, half black, 13 of each. Suit, 4 of each card. Aces are 1. Picture cards, there's 12. And there's 3 in each suit. So you may want to use this as a little guide to help you on questions about cards. Right, so have a go at some of the questions for today. Hopefully this video will help you. If you got this far, well done, and let me know if you have any problems.